3.4 States of matter. Key ideas in this section: what are some properties of gases, and how can you predict the effects of pressure, temperature, and volume changes on gases? So gases expand to fill their containers, the container that they're in, and so that is a unique property of gas. Solids and liquids don't do that. Gases spread out easily and mix with one another. They also have low densities and are compressible. So compressible means that you can compress them down into a smaller volume if you need to. Again, solids and liquids don't do that. So unlike solids and liquids, gases are mostly empty space, and that means that you can compress them down. Also, gases exert pressure on their containers. To predict the behaviors of gases, we have the gas laws that help guide us. And this is important because we deal with gases every day, and in every situation that we're in. Gases surround us in the air that we breathe and in some of the things that we use every single day. And we need to know how they behave so that we can work with them safely. And so the gas laws state the mathematical relationships between volume, temperature, pressure, and quantity or amount of a gas. So the first law is called Boyle's law, and it relates the pressure of a gas to its volume. So Boyle's law says for a fixed amount of gas, you've got one certain amount of gas at a constant temperature. Temperature's the same, amount of the gas is the same. If the volume increases, the pressure will decrease. Likewise, if the volume decreases, pressure will increase. So if you think about like a balloon the volume of the balloon can expand. And so when the balloon expands, the pressure inside is decreasing. And then if you squeeze on a balloon, or anything with a gas inside, but if you squeeze on a balloon, you can kind of decrease the volume a little bit, but the pressure inside will increase. And so Boyle's law, the math equation is P1V1 equals P2V2. Now there are 3 gas laws that we're going to go over. This is the first one. What I really want you to know is what happens when. You don't have to know the math. You don't have to know all the extra details, but I want you to know at a certain temperature for a certain amount of a gas, if I increase volume, pressure will decrease. If I decrease volume, pressure will increase. The next one we're going to look at is Gay-Lussac's law. He was French. He has a weird looking name. So Gay-Lussac's law relates pressure to temperature. And so the pressure of a gas increases as temperature increases if volume doesn't change. So you've got a certain amount of gas in maybe like a metal container, something that the volume's not going to change in. If that gas heats up, then the pressure will increase. And we know that. We should know that just from everyday experiences. Also, if temperature decreases, then pressure will decrease. A lot of times in this time of the year, in the fall time of the year, because you have these like hot evenings, but really cool nights and mornings, a lot of times you'll get like a light come on in your dashboard of your vehicle saying that you need to add some air to your tires. Because what's happening is in the evening that temperature is increasing, so the tire pressure will increase. But in the night and the morning, the temperature is decreasing, and so the tire pressure will decrease, and then your car will sense that it needs extra air in the tires. And then the third law relates temperature to volume. So for a certain amount of gas, at a constant pressure, the volume of a gas would increase as temperature increases. So volume goes up as temperature goes up. Volume goes down as temperature goes down. So thinking about a balloon again, because if you kept it at the same pressure, the volume of a balloon, it can shrink or expand or shrink. So if you have a balloon outside on a hot day, the volume of the gas or the balloon is going to increase. And then if you maybe put that balloon in a refrigerator, freezer or something, why you would, I don't know. But just to test it out, then the temperature is going to decrease, so the volume will decrease.